Hello guys, I'm Ronald from MathX, and today we're solving the number 17 from the 2020 AMC 8. Now this problem, in my opinion, does not deserve a place of number 17, because when you get down to solving the problem, you can just use simple factoring to finish it and get your answer. But anyways, without further ado, let's get started. How many positive integer factors of 2020 have more than 3 factors? As an example, 12 has 6 factors, namely 1, 2, 3, 4, 6, and 12. And the answer choices here are 6, 7, 8, 9, 10. So the first step into doing this problem is getting the prime factorization of 2020. And through simple methods of getting the prime factorization, namely factor trees, which are a very simple and effective way, we will get 2 squared times 5 times 101. So then there's this special formula that can find out the number of factors of a number based on its prime factorization. Now this method is really useful in a lot of competitions, so make sure to take note of this. So what we'll do here is add 1 to its exponent here. So when we add a 1 to it, we'll have 3 from 2 squared having exponent plus 1, we'll get 3. Then we have to multiply it by the exponent of 5. And 5's exponent will be 1 in this case, because 5 to the 1 is going to be 5. So then we have to multiply it by 2. And then same for 101, it's going to have an exponent of 1, so also multiply by 2. Now, the next step is that we have to find out the factors that only have 2 factors. But we know what those are going to be. Those are going to be prime. So that means the factors that only have the 2 factors is going to be 2, 5, and 101, which are all going to be factors of 2020 with less than 3 factors. So let's note that down somewhere. 2, 5, and 101. Now, the next step we are going to do is find out the only square of the number as a factor of 2020. And that number is going to only be 4. So we would have 4 also included in this list. And the reason why it's going to be 4 is that 4 is the only factor of 2020 as the square factor. Because as you see in the prime factorization, it only has 2 2's. So that means the only square in this case would be 4. And 4 doesn't have more than 3 factors. It only has 3. It will have 2, 4, and 1. So we can include that in our list. Now next, we just include 1. Because 1 only has 1 factor, and that's going to be 1. So we can just include that here as 1. Next, we can subtract this list of factors from the total amount of factors we got. And that will be equal to 12. So we'd have 12 minus 5 is going to be equal to 7. And that is going to be answer choice B. So let's mark that here. As you can see, this problem just required simple factoring, and we got this answer very quick. But anyways, as you can see, we have solved this problem, meaning we are now officially finished.